All right, so in the previous part of the lesson, I kind of just made the shaded region that showed all the solutions. We're now going to slow down, make sure we understand exactly how to make that shaded region that shows all the solutions. And there are several things that I'm going to want you to be careful of as you put all this together. Here we go. It basically boils down to this. One, we're going to graph what's called the boundary. For what we do, that's going to be a line of some kind. And then two, we'll talk about how you can make sure that you shade appropriately. There are a few ways to get that done. Here we go. First off, for the graphing of the boundary, we're going to take the inequality we have and just for a moment, pretend that it's not an inequality. Let's pretend it's an equation. Because the boundary of the inequality is the same as the line you get if you graph it as an equal sign instead. Let's refresh. It may have been a little while for you. The number at the back, that's your y-intercept. This is called the slope-intercept form because the number in front of the x tells you what your rate of change is, the slope of the line, and the number at the back tells you where on the y-axis your line starts. So let's put a point on the y-axis at 5, positive 5. There's your starting point. To get to another point on the line, you need to then use your slope number. Now, negative slopes end up going down. So this means I should be going down 6 spots every time I move to the right 5 spots. So starting from here, go down 1, 2, 3, 4, 5, 6, and to the right 1, 2, 3, 4, 5. Put another point. These are the 2 points through which you're going to draw your line. Now, before I draw the line, we have a choice to make because it turns out there are 2 types of boundary lines. There's this type, which is where you actually say, hey, I want to include the numbers that are on the boundary. But there's a second type. It looks like this. It's a dashed boundary line. This says, hey, I want to come right up to this edge, but I don't want to include the edge. And so this is the difference. When you have the solid line, you are saying, I want to include the boundary. But when you have the dashed line, we're saying, hey, I do not want to include the actual boundary line itself. Think of it as the difference between a fence that is kind of part of the structure and a fence that you don't want to touch. That's kind of the difference there. Here's how you tell. I'm going to just move these words up over here to the side. The way you tell is you now go back and look at the inequality itself. If you have a greater than or a less than, you want this dashed boundary. If instead you have a greater than equal or a less than equal, then you want the solid boundary. Because the equal means, yeah, I want to include the equation part of it. This means I don't want the equation part of it. I only want the above or below part. So as I look at this, this is just a greater than. That means the line that we make through these 2 points should be a dashed line. So as I get my line maker here, put things up, I'm going to make sure that I make this a dashed line. A little skinnier, make it dashed. I'm also going to make it red. And there we go. We've got our boundary graphed. So it was a 2-parter, right? Let's review those 2 parts. First, put your y-intercept, use your slope to find a second point so you can make your line. And then second, pay careful attention to the inequality symbol to see whether you want the solid boundary line or the dashed boundary line. Okay, once that's done, to show the solutions to the inequalities, we're either going to shade in everything up here, or we're going to shade in everything down here. But which is it? For that, I recommend doing some testing. We're going to do a test check. by picking a point. And it doesn't matter which point you pick. It really shouldn't be one that's on the line, though. So when you're picking your test point, pick some point that is either off to the side or maybe over here. I recommend choosing 0, 0 if you can. The reason? It's just often the easiest one to use because multiplying by 0 is super easy. Here's what we're then going to do. We're going to put this in for the x and the y, and just like we did before, see whether we get something true or get something false. So let's do that. 0 in for the y, 0 in for the x, and simplify. 0 times negative 6/5, well, that's just 0. So it's 0. And then 0 plus 5 is just 5. Now we've got to ask ourselves, is this true? Is 0 greater than 5? No, 0 is less than 5. This is false. That means 0, 0 is not a solution. And here's the beauty of it. If this ordered pair doesn't solve the inequality, no ordered pair over here solves the inequality. So this is not the side I want to shade on. I want to shade on this side. Now let's just imagine, though, that you don't quite trust that yet. You want to check, get a solution that works. Let's now pick a second test check. This time on the other side of the line, of the boundary. So pick a point that's over here. Again, there's not a right and wrong choice, but there are easier and less easy choices. I'm going to recommend, if you can, pick a point on the y-axis. The reason for that is that if your x is 0, that means I don't have to deal with this fraction very much because we're going to multiply by 0. It ends up being nothing. So for our second test check, let's see what happens. Put a 6 this time in for the y. We're checking to see if I put a 0 in for the x, do we end up with something true this time? Well, negative 6/5 times 0 is just 0. 0 plus 5 is 5. Is 6 greater than 5? Yes, this is true. That means that this ordered pair up here, that 0, 6, is a solution to the inequality. But more than that, if the 0, 6, this point above, is a solution, then so is every other point above. So this has let me know my shading this time needs to go above the boundary line. So now anybody who looks at my work can say, okay, the points that solve this inequality are in this shaded region, the yellow area above the boundary line, and I can see that because the boundary line is dashed, I do not want to include any ordered pairs that are on the boundary line. What I mean by that is, let's just do one final quick test check here. If we pick a boundary point, like this one right here, the 0, 5, I'm just going to make a note here. We're just doing a final kind of boundary check at the ordered pair 0, 5. If we put that in, we're going to end up with eventually the statement. Well, I'll tell you what, let's run through the calculations. So is 5 greater than negative 6/5 times 0 plus 5. So we're asking, is 5 greater than 0 plus 5? Is 5 greater than 5? You see, oh man, you kind of almost want to say it's true, but it's not. 5 is not bigger than 5. So this is another false statement. That's why we dash the boundary to show that, hey, if you're on this line, man, you're very close to being true, but you're not there yet. So dash the boundary means don't include the points that are on that line. Okay, recap. Graph your boundary. Pretend it's an equation. This was just greater than, so we wanted a dashed boundary line. And then pick a couple test checks to see which side you should shade on. Let's go again. We'll go a little bit quicker this time. First, treat it like an equation. So start at a height of negative 1. The slope this time is positive, so your line should go up. 1 to 3 means go up 1 and to the right 3. So up 1 and to the right 3. make our line through those points. And I know it's not in the right spot yet. I'm going to try to get the angle right and then move it. All right. This has see how it's got the little equal to underneath this time? That means I want a solid line. So I'm going to leave the line solid, make it a little thinner. There's our boundary line. Now let's see which side we should shade on. For our first test check, I'm going to always recommend using 0, 0. It's the easiest. The only time you shouldn't pick that as your first test check is if it's a point that's actually on the boundary line. Then don't pick it. But otherwise, use that one. So is 0 greater than or equal to 1/3 times 0 minus 1? Well, 0 minus 1 is just -1. Is 0 greater than or equal to -1? Yeah, it is. So that tells me 0, 0 made the inequality true. Oh, I didn't want that. I wanted a highlighter. Made the inequality true. Therefore, so will every other point that is here above this line. Now on your papers, since you don't have this little fancy highlighter, I recommend you can just do some scribbling with your pencil or we also do what's just called like a hatch. So you could do like lines like this. That's a good way to show, hey, I want all the stuff that's up here. Just to make sure, let's do another test check. And I want to make sure that what I end up with isn't actually a solution. So I'm hoping that if I pick a point from down here for my second test check, I hope I end up with something that isn't true this time. I'm going to pick, how about this point? Any point over here will do. So I'm checking to see, all right, -3 for the y. My ordered pair here was 6, -3. -3 for the y. Is that greater than or equal to 1/3 times 6 minus 1? Well, 1/3 of 6 is 2. 2 minus 1 is 1. Is -3 greater than or equal to 1? Nope, that's false. But that's good. That's what I wanted. I didn't want this point down here to work because this is the unshaded region. Now, here's the thing. It turns out there is another way to check and make sure that you've shaded on the right side of the line. If you have, as we have, if you have an inequality in slope-intercept form where the y is already by itself on the left, then anytime you have a greater than, you're going to be shading above the line. Down here, we had a greater than, we're shading above the line. And if it's a less than or a less than equal, the shading would be on the other side. You would be shading below the line. So you've got a few choices as to how you decide which side to shade on. I do recommend, though, always doing a test check to make sure that you've got things in the right spot. Let's turn this into some toolkit stuff. So what have we seen? The solutions to two variable inequalities are represented as shaded regions. That's the highlighting, the coloring in, or the hatching that you can do. The boundary on the graph is a dashed line if you have a less than or a greater than, but it's a solid line for a less than equal or a greater than equal. When y is on the left, less than and less than equal to end up being shaded below. I'm going to just put down here a note. Make sure you do some test checks just to be sure. And if you have a greater or greater than equal, it ends up being shaded above. So as you start working through your practice, specifically on the core practice sheet, make sure you check those answers. And if you're not matching up and you're not sure why, check in with a friend or neighbor or with one of your teachers.